Hello students, next we'll go to priority scheduling. So in my previous video I have explained you about priority scheduling. So in this case what happens, we are checking the priorities. So in the previous algorithm we were checking whichever process having the shortest burst time, but here what you're doing, you're checking whichever process is having higher priority, that particular process will be given the CPU first. Okay, so this priority can be either smaller number is having higher priority or higher number is having higher priority. Okay, so in our textbook what they're saying, lower priority number. So what they're saying, lower priority number is having higher priority. This is if they have not given anything in your question. Sometimes in the question they will mention as higher number is having higher priority. In that case you have to consider the same order. When nothing is given, by default will say lower priority number is given higher priority. So please don't get confused here. Okay, so when this priority you're going to select, so it might be having processes where two processes both are ready to execute. In that case you can check for the priority, whichever is having the higher priority you can consider that particular process to execute or get the control of CPU first. Okay, again same thing here, you have to calculate the waiting time as well as the average turnaround time. So we'll draw the Gantt chart. Okay, so arrival time is not given to you, so we are assuming arrival time equal to 0 millisecond. When they are not giving you any arrival time, you have to assume it as 0. Okay, and one more assumption you can write, since they have not given anything in the question, assume lower priority number is having higher priority. You can write like that, is having higher priority. So we'll start with the Gantt chart. So Gantt chart begins with the arrival time 0. Okay, so here arrival time, what we are saying, all the priority, all the processes are coming in at arrival time 0. Okay, so since all the processes are coming in at arrival time 0, you just have to check for the priority. So out of this, which is having the higher priority? So we said lower priority number is having higher priority. According to this, P2 is the first process which will be given the CPU and which can exist. So how much time it takes? 1. So here we are speaking about non-preemptive. Non-preemptive means what? Once you give the CPU to particular process, you cannot forcibly take. So the process has to complete. Only then the CPU can be given to other process. Okay. So P2 takes how many milliseconds to complete? 1 milliseconds to complete. Okay. Now P2 is completed. Which is our next process which is having higher priority? That is P5. So you are writing P5. And how many milliseconds it requires to complete? It takes 5 milliseconds to complete. So this 5 plus 1, it will go up to 6. Okay, so now P5 is done, P2 is done. Which are remaining? 3, 4, 5. Out of that, lower priority number is P1. Okay, so next you give it to P1. P1 takes how much time to complete? It takes 10 milliseconds to complete. So 10 plus 6, it will go up to 16. Okay, so now pending one is only P3 and P4. Out of that, which is having higher priority? P3. P3 takes how much time to complete? 2 milliseconds. So the 16 plus 2, it will go up to 18. And finally left out is only P4. How much time it takes to complete? P4 takes only 1 millisecond to complete. So you will go up to 8 plus 1, that is 9 millisecond. Just compare 10, 15, 16, 17, 18, 19. Yes, it is correct. Okay. Now what you have to do, you have to calculate the waiting time. Waiting time for each of the process. What is the waiting time for P1, P2, P3, P4 and P5? What is the waiting time for P1? P1 has come in at 0 millisecond. At what time it got the CPU? So the starting point, that is left side of this, is when it got, and right side of this is when it received. Okay, so P1 has come in as 0 millisecond, but it got the CPU at 6 millisecond. So 6 minus 0 is 6 millisecond. You don't have P1 again anyway, so it is just 6 millisecond. Then P2 came in at 0 millisecond. It got the CPU at 0 millisecond. So 0 minus 0 is 0 millisecond. P3 came in at 0 millisecond, got the control of CPU at 16. 16 minus 0 is 16 millisecond. Next P4 came in at 0, got at 18. So 18 minus 0, that is equal to 18 millisecond. Next P5 came in at 0, got at 1. So 1 minus 0, that is 1 millisecond. Now I have to calculate the average waiting time. How you can calculate? 6 plus 0 plus 16 plus 18 plus 1 divided by how many number of process? 2, 4, 5. So how much you're getting? 41 by 5 is equal to 8.2 millisecond. Next one, you have to calculate the turnaround time. So what is the formula to calculate turnaround time? That is nothing but burst time plus waiting time. So for P1, what is the burst time for P1? Burst time for P1 is 10 millisecond. So 10 plus what is the waiting time? 6, that is equal to 16 millisecond. For P2, burst time is 1 and waiting time is 0. So 1 millisecond. P3, burst time is 2 and the waiting time is 16, that is 18 millisecond. P4, burst time is 1 and waiting time is 18, so it is 19 millisecond. P5, burst time is 5. Okay, burst time is 5 and waiting time is 1, that is 6 millisecond. Now you have to calculate the average turn around time. That is nothing but 16 plus 1 plus 18, 19 plus 6. That is how much you will be getting, divided by how many number of processes. How many number of processes you have 5. You have 5 processes. So that is nothing but 60 by 5, that is equal to 12 millisecond. So this is how you have to solve for non-preemptive priority scheduling. Okay, if they have not mentioned anything about the priority, you have to write assume lower priority number is given higher priority. If they given in the question, then not required, otherwise you have to write. Hope you have understood this problem. Thank you.